Welcome students, we've been given this question: integral m raised to the power of ax positive b times dx, where m is a constant. Now you need to be very careful when you have an integral of this form. So foremost, what I wish to do is I would like to take ax positive b to be equal to some t, and then I will differentiate both sides. Differential of a times x would give me a into dx, differential of b is 0, differential of t is dt. So dx can be rewritten as dt over a. So this integral is rewritten as integral m raised to the power of t. In place of dx, it's going to be dt over a. I would like to rewrite this as 1 over a times the integral m raised to the power of t times dt. Now I would like to make the following substitution. Let say sum u be equal to m raised to the power of t. Now if you were to differentiate this, the differentiation is as follows. On the left, differential of u is going to be du. On the right, differentiation of m raised to the power of t is going to be m raised to the power of t times ln of m. This is multiplied with the differentiation of t. So that is the rule, have that in mind. Because in place of t, if you were to be given say t squared or t power 3 or some function of t, then this formula will come in handy. So having mentioned that, this is going to be rewritten as du is equal to m raised to the power of t times ln of m, differentiation of t, right? That's going to be dt. So this can be further rewritten for dt. So dt is equal to du over m raised to the power of t times ln of m. So in place of dt, I'm going to substitute this value. So this is rewritten as 1 over a times integral m raised to the power of t is equal to u. In place of dt, it's going to be du over m raised to the power of t times ln of m, right? But this m raised to the power of t has to be replaced. So I'm going to rewrite this as 1 over a times integral u times du over, in place of m raised to the power of t, I will be substituting u followed by ln times m. Now this is with regard to u, but this is going to be constant because it contains no u. So I'm going to rewrite this as 1 over a times ln m integral. A u and a u can be cancelled, giving me du. So if I were to integrate this is going to be 1 over a times ln m. Integral of du is going to be u. But what is u? That's m raised to the power of t. Substitute that, divided by a times ln m. But my t is equal to a raised to a times x positive b. Replace that. So that's going to be m raised to the power of ax positive b divided by a times ln m. Since it's indefinite integral, an arbitrary constant has to be added. So this is the solution for this integral m raised to the power of ax positive b times dx. In fact, you can remember this as a formula, so that if you find this in multiple choice question and a choice like this comes up, you will be in a better position to immediately choose this. So having mentioned that, we will again meet in another session where I will be handling interesting questions on integration. Thank you students, enjoy your day.